A translation is the movement of a shape along the x and y axes without rotation, and this movement is determined by the values of two numbers. The first number gives the movement along the x-axis, and the second number gives the movement along the y-axis. Look at this example. Here is our original shape, and we have been asked to move this shape 4, 0. This means we move the shape 4 places along the x-axis and 0 places along the y-axis. And by moving the shape 4, 0, we have arrived at this position. In this example, we have been asked to move the shape using the coordinates 0, 4. The 0 refers to no movement along the x-axis, and the 4 refers to movement of 4 places along the y-axis. So moving the shape using the coordinates 0, 4, we arrive at this position. In this example, we have been asked to move our original shape using the coordinates 4, 3. The 4 indicates movement of 4 places along the x-axis, and the 3 indicates movement of 3 places along the y-axis. So moving our original shape by using the coordinates 4, 3, we arrive at this position. Remember, like true coordinates, the first number relates to movement along the x-axis, and the second number relates to movement along the y-axis. Like coordinates, these numbers can be either positive, negative, or a mixture of both. In this example, we have been asked to move this shape by using the coordinates -2, -2. This means the shape moves back 2 places along the x-axis and down 2 places along the y-axis. So by moving this shape using the coordinates -2, -2, we arrive at this position. A translation is where an object is moved from one position to another, and we use vectors to describe the direction and distance of this movement. Vectors are written as x over y, where x is the value of the movement in the x-axis and y is the value of the movement in the y-axis. In other words, the top number represents the horizontal movement and the bottom number represents the vertical movement. You should note that values for x and y can be positive or negative numbers, depending on the direction of the movement. We want to translate this triangle from the start position to position 1. And in order to describe this movement, we use vectors, which give values for the horizontal movement and the vertical movement of the original triangle. The first thing we have to do is select a point on the shape which acts as a common reference point for both images. Here we have used the bottom left-hand corner, but you can use any point in the shape. To arrive at our new position, the original shape has to move 5 units to the right, so our value for x in the vector is 5. The original shape is also to move 3 units up on the vertical axis, so the value for y in our vector is 3. So 5 over 3 is the vector that describes the movement of the original shape to its new position. 5 across and 3 up. Remember, depending on the direction of movement, these vectors can be positive or negative numbers. In this example, we want to move the original shape to position 2. In order to do this, we must move the original shape 2 across and 7 down. So the value for x in our vector is 2, and the value for y in our vector is -7. The y factor is -7 because the value of the y is lower than that of its original position. Here we want to move the original shape to position 3. In moving the original triangle to position 3, we have to move the triangle 3 places to the left. This means we reduce the value of the x by 3 units. So the value of x in our vector is -3. Similarly, to arrive at our new y position, we have to reduce the value of y by 7 units. So the value of y in our vector is -7. Remember, a translation is where an object is moved from one position to another, and we use vectors to describe the direction and distance of this movement. The top number in a vector indicates movement along the x-axis, and the bottom number in the vector indicates movement along the y-axis. And the values of these vectors can be positive numbers, negative numbers, or a combination of both types of number.